Okay, we have written another integral. This one's from the Florida Integration Bee 2016, problem 6. We have the integral of this whole long expression that I barely fit on the board, dx. Now, to get started, it looks like two things. It looks like we need, the first thing I think about is a substitution where the input, we've got kind of complicated inputs on everything. I also think I need to do some factoring. And with the plus sign, I'm thinking it's some kind of reverse product rule if we can clean it up first. To start, what I can do here is just complete the square. If we start with, the 5 comes from taking 1/2 of this. So we have, if we start with x plus 5 squared, this is going to be x squared plus 5x is 10x plus 25. To get back to 26, I need to add a plus 1 right here. But now I notice that we have x plus 5 in common here and here. What if I do a u substitution to kind of clean up this and this, and then hopefully this thing gets a little simpler. So I'm just going to make a simple substitution, u equals x plus 5 just to clean it up, and then du is going to be dx. And then let's just rearrange this and get a value for 1 minus x because we have it right there and there. If you do that for 1 minus x, just doing the algebra, you're going to end up with 1 minus x is equal to 6 minus u. So now we'll go ahead and substitute all this. First with cosine, using our value of 1 minus x, this becomes 6 minus u here. Then this part, where x plus 5 now is u, this is just going to be 1 over u squared plus 1. And then our tan again is going to be, so tan is going to be 6 minus u. And then this here is just going to become arctan of u. And then here what I want to do is let's actually just distribute in this cosine 6 minus u and see what it looks like there. So then we're going to have cosine 6 minus u over u squared plus 1. And then when you multiply cosine times tangent, the cosines are going to cancel this tangent sine over cosines. This is actually just going to become sine 6 minus u times arctan of u. And now this is starting to look pretty good because the derivative of arctan, if we just kind of create a 1 here, is going to be 1 over u squared plus 1. The derivative of cosine is almost this right here. One thing I want to do to clean this up, I can actually reverse the 6 minus u and write it as u minus 6. So if we do that, cosine's an even function. So reversing the sign is not going to really bother it. So we can just change. So with the cosine, we can just change this, no problem. On the sine, I want to do the same thing because we want the same angle. The only thing is sine is an odd function. So when I do this, I need to bring a minus sign out front. But then now for our reverse product rule, we can just kind of label things. If arctan is f, then we have our f prime here, just including this 1 on this. And then if we call cosine u minus 6, if we call that g prime is going to be minus sine u minus 6 over here. So what we have here is set up perfectly for the reverse product rule. For the product rule, our formula is just fg prime is going to be f prime g plus fg prime. And so what we have here is inside of an integral, but here if we're integrating a derivative, we're just going to get back f g plus c. And so putting this together to finish it, all we need to do is grab our f and g values. So our f again is arctan of u, our g is cosine u minus 6. So what this is going to reduce to is just cosine u minus 6 and then arctan of u. But then let's just back substitute in order to finish this. So first, on the cosine u minus 6, I can put this back because again, it's an even function. So I can write it like this and we can write it as cosine 1 minus x. And then u is x plus 5. So we have arctan x plus 5, add a plus c, and that's it. All right, there it is. Another good one from the Florida Integration Bee 2016. Thanks everyone for watching. Have a good day.